We're all pretty used to thinking of AI as a co-pilot, right? A smart assistant that helps us out. But what if we built entire societies of AI agents? How would they actually work together, make decisions, or even argue? Today, we are diving into a really radical blueprint for how AI collaboration might actually work.
So I want you to really chew on this question for a second. We're not just talking about building better chatbots here. We're asking a much bigger question. What kind of fundamental rules, what kind of architecture would you need for groups of autonomous AIs to work together on really complex problems? The way human teams do.
All right, so here's our roadmap. We'll start by digging into the big problem today, what I'm calling the AI teamwork paradox. Then, we'll explore a wild new blueprint built around this idea of a topic. From there, we'll see how these topics use debates or collisions and a permanent ledger to agree on things. We'll even unpack the math that keeps it all fair before zooming way out to see what this all means for reality itself.
Okay, first up, the AI teamwork paradox. We have these incredible AI models that can code or write poetry like a bona fide genius. So why is it that when you try to get them to work together in a team, they kind of fall apart? It's a super fascinating problem.
So for the last few years, we've been living in what you could call the co-pilot era. The AI is this brilliant partner, but the human is always the pilot calling the shots. The next big thing, the real frontier, is multi-agent systems, actual teams of specialized AIs that collaborate. But, and this is a big but, it's not as simple as just throwing them all into a group chat and hoping for the best. There's a huge obstacle.
And here it is. The number one challenge is something called context pollution. Just imagine it. You put a bunch of different AI agents into a shared space, they all start dipping into the same pool of knowledge, and pretty soon they're pulling up conflicting info, outdated facts, or just plain wrong stuff. That's what leads to errors and hallucinations, and the whole collaboration just grinds to a halt.
So, how in the world do you solve for context pollution? Well, you need a totally new foundation for how these things collaborate. And that brings us to the core idea of this whole system, the topic.
A topic is way more than just a project folder or a Slack channel. Think of it more like a self-contained little universe, a context container. It holds all the relevant data, every task, all the work for one specific project. Inside a topic, context pollution is literally impossible because the reality of that project is perfectly defined and totally sealed off from all the outside noise.
Now, this is where it gets really wild. In this system, everything is a topic. A project? That's a topic. A team, also a topic. But get this, a human user is a topic. An AI agent is a topic. This is a massive philosophical shift. It basically says that humans and AIs are the same kind of entity in this system, putting them on a totally level playing field to work together as actual peers.
Okay, so if humans, AIs, and even projects are all topics, how do they actually interact with each other? Well, it's not through messy email chains or endless meetings. It's through this really structured process of debate and building consensus, and everything gets recorded on a permanent ledger. Let's see how it works.
Now, I know what you're thinking. The word collision sounds bad, right? Like a car crash? But in this world, it's the exact opposite. A collision is a constructive, data-driven debate. It's the formal process where different topics, let's say a researcher agent, a human strategist, and maybe a legal AI, come together, hash things out, and argue their way to a final decision.
And this visual just nails the power of that process. Look at the left. That's a raw idea. It's like a single, simple note in a song. Now look at the right. After that idea has gone through a bunch of these debates, these collisions, it's become this rich, complex chord. It's not just a flat piece of information anymore. It has a history, it has context, it has depth, all from the arguments that shaped it. And hey, the proof is right there in the data. That simple idea on the left, it exists in one single state, one clear point. But after the debate, on the right, you can see the idea is smeared out across all these different possibilities. Each one of those little peaks represents a different argument or perspective that became part of the final synthesis. That complexity is the evidence, the fingerprint of a rich, verifiable history.
And here's the best part. The outcome of every single one of these debates is recorded on an immutable, unchangeable ledger. What this does is create a permanent and totally verifiable chain of thought for every single decision that this AI society makes. You know that whole black box problem with AI where we have no idea how it got an answer? With this, it's gone, solved. It's all right there on the ledger for anyone to see.
So, we have a perfect, permanent record of every debate.
But that opens up a whole new can of worms, doesn't it? In a team that's a mix of humans and AIs, how do you figure out who gets the credit? How do you know who really added the most value? For that, you need a kind of mathematical referee.
So let's just ask the question straight up. In one of these hybrid teams, how do you fairly measure who contributed the most? Was it the AI that came up with the brilliant first idea? Was it the human who tweaked it and saw its real potential? Or maybe it was the compliance bot that saved the whole project from a massive lawsuit? It's a really tricky problem.
Well, the answer comes from this beautiful concept from game theory called the Shapley value. And honestly, it's way more intuitive than it sounds. Here's how it works. To find any one person's or agent's true contribution, you basically run a thought experiment. First, you look at how well the team did. Then, you pretend that one member was never there, and you see how much worse the outcome was. You do this over and over again for every possible combination of teammates. The average impact that member had across all those scenarios, that, my friends, is their true value. It's a mathematically provable way to be fair.
So what happens when you put all these pieces together? You've got topics as your building blocks, collisions for structured debate, a permanent ledger for total transparency, and Shapley values to keep it all fair. What you end up with is something way, way bigger than just a new collaboration tool. You get a blueprint for an entirely new kind of organization, the Agentic Enterprise. It's almost like an operating system for reality itself.
Let's just put it side by side. In the old world, AI is a chatbot you tack on the side. Context gets lost in a million different channels, and the human's job is basically to tell the machine what to do. The final decision? It's a black box. But in this new model, AI is a proactive member of the team. Context is perfectly preserved inside its container, and the human's role shifts to high-level strategy and validation. And the most important part? Every single decision is completely auditable.
And that complete traceability enables something that sounds like it's straight out of science fiction. Forensic reality. Because every single interaction is carved in stone on that ledger. If something goes wrong, if you find a bad block, you can trace it all the way back through the chain of debates to find the exact collision, the exact moment where the error was introduced. It's the ultimate form of accountability.
But what's truly mind-blowing is just how universal this model really is. Think about it. Whether it's atoms colliding with kinetic energy at stake, or animals competing for survival, or nations negotiating over resources, it's all the same fundamental pattern. You have different entities colliding, each with a stake in the outcome, leading to some new emergent reality. This isn't just a model for software. You could argue it's a model for reality itself.
So, I'll leave you with this final thought to wrestle with. If every single decision in our companies and our governments, everywhere, is perfectly recorded, with every contribution mathematically weighed and its origins completely traceable, what does that actually mean for the future of how we work, for our politics, and maybe even for our very definition of truth?